next is, so find the value of k such that the system of equation has non-trivial solution. So this is find the value of k. Find the value of k such that the system of equations has non-trivial solution. So equations are x plus ky plus 3z equal to 0, 4x plus 3y plus kz is equal to 0. Third is 2x plus y plus 2z equal to 0. These equations have unique solution. This has unique solution. So these equations have unique solution. So my aim is to find the value of k so that this system of equation has unique solution. So first convert this equation in the form of matrix form. So this is equal to, in this form, 1 k 3 4 3k 2 1 2, and this is x y z, and this matrix is equal to 0 0 0. So step number 1, so convert these system of equation in the matrix form. So statement is this has non-trivial solution. So just non-trivial solution, not a unique solution, it has non-trivial solution. So my aim is to find the value of k if it has non-trivial solution. Now the equations has non-trivial solution if determinant of a is 0. So what is this? It is ax into 0 matrix. Now the system of equation, the system of equation has non-trivial solution if determinant of a is equal to 0. So this is possible if determinant of is equal to 0. So determinant is, which is 1k 3 and 4 3k 4 3k and 2 1 2. So 2 1 and 2. Now simplify this determinant, we get this is equal to 1 into 6 minus k minus k, which is 8 minus 2k, and this is plus 3, and it is 4 minus 6 equal to 0. So this is possible if 6 minus k, which is minus 8k plus 2k square, so this is minus 6 equal to 0. So this minus 6 and 6 cancel to each other. So this is a minus 9k plus 2k square. So if minus 9k plus 2k square is equal to 0, so this implies it has two values. So this can be written as k into 2k minus 9 equal to 0. So this is possible if k is equal to 0 or k is equal to 9 by 2. So the given system of equation has unique solution if value of k is 0 or 9 by 2. Now this is the first question of homogeneous linear equation. Now second question is the statement of second question. The statement of second question is find the non-trivial solution of the system of equation if possible. So this is a question and statement is find the non-trivial solution of system of equations. System of equation. So system of equation is x minus 2y minus 3z is equal to 0. Second, minus 2x plus 3y plus 5z is equal to 0. And third is 3x plus y minus 2z equal to 0 if possible. So find the non-trivial solution of the system of equation if possible. So my aim is to find the non-trivial solution of this equation. So step number 1, solution. So first write this equation in the form of matrix form. So this is equal to 1 minus 2 minus 3 minus 2 3 5 3 1 and minus 2, and this is x y z, and this is equal to 0 0 0, and this equation can be written in the matrix form. This is basically A matrix, X matrix, and this is a 0 matrix. So first step, reduce this matrix into matrix form. Reduce the system of equation into matrix form. Now, in order to reduce it in the row reduced echelon form, so I used R2 which is R2 plus 2R1, R3 which is R3 minus 3R1. So this will become first row same 1 minus 2 minus 3, and second is multiply by 2, then add 0 minus 1 minus 1. So here multiply by minus 3, then add, so this is 0, 6 plus 1 7, so this is a 9 minus 2 again 7, and this is a x, y, z, and this is the same as 0 0 0. So this is my first step. Now second step is, so reduce this term as a 0. Now to operate this term as a 0, so we apply a row formula which is R3 which is equal to R3 plus 7R2. So what this become? So first row is same 1 minus 2 minus 3, second is 0 minus 1 minus 1, third is 0 0 0, and this is x y z. This is x y z. Then this value is equal to 0 0 0. This values. Now we can also reduce this term as a 0, and this is now here this part is, this equation is, we reduce this equation into row reduced echelon form. So these are the diagonal entries, and all entries below these diagonal are 0. So it means this equation is converted as x minus 2y minus 3z equal to 0 minus y minus z equal to 0. So we got two equations. So what is y? Y is equal to minus z. When we substitute this equation in this equation, so we get the equation in term of x and z. So when we substitute, this will become x plus 2z minus 3z equal to 0. So here x we get equal to z. So y is minus z and z is again z. So if I substitute the value of z, which is equal to, if I substitute the value of z, which is k, so what is k? K is some parameter. If k is some parameter, then x is equal to k, y is equal to minus k, and z is equal to k. So this is a solution of the given equation. So it is an infinite solution. So these are the non-trivial infinite solution. So in this way we can find the value of the solution of the given equations. Now after that we are going to start a very important question. So that is a solve completely the system of equation. So how we can solve the system of equation? So statement is solve completely solve completely the system of equations. Solve completely the system of equations. Now, the given equation are x plus y plus z equal to 0, 2x minus y minus 3z equal to 0, 3x minus 5y plus 4z equal to 0, and next is x plus 17y plus 4z equal to 0. So this is a system of equations. So my aim is to solve the system of equation. Now, first step is to write this equation in the matrix form. So what is that matrix form? So this is a 4 row and 3 columns, 1 1 1, 2 minus 1, 2 minus 1, minus 3. Next is 3 minus 5 and 4, 1 17 and 4 into x y z, x y z, and this is a 0 0 and 0, right? So this is equation number 1. Now we will reduce this equation into row reduced echelon form. So in first step, my aim to make it 0, to make it 0 and to make it 0. So in order to make these terms 0, I will apply the row operation R2, which is R2 minus 2R1, R3, which is R3 minus 3R1, R4, which is R4 minus R1. So this will become a 1 1 1. So this is 1 1 1. So this will be 0 minus 2. So this is a minus 3, and again minus 2 minus 3 minus 5. Now minus 3, so this will become 0, minus 8, this is minus 3 minus 3 plus 4, 1, and next term is, this is 0, this is 16, and this is 3. So this term is 3, and this term is x y z, and this term is 0 0 0. So this is my second step. Now in the third step, I need this term as 1 and the remaining term should be 0. This and this term should be 0. So in order to reduce this term 0, so we multiply first, this is as 3 multiplied by 3, this is again multiplied by 3, yeah, or we can make it as, so just operate as R2, which is equal to minus 1 by 3 into R2, this term. So this will be helpful to operate the next step, x, y, z. So this will be 0, 0, 0, and this will be 1, 1, 1, 0, 1, and this is 5 by 3. So here it is 0, minus 8, 1, 0, 16, 3. So this value. Now after that, to make this term 0 and to make this term 0, I will apply the operation R3. So which is R3 plus 8R2 and R4, which is R4 minus 16R2. So this will become a 1, 1, 1, 0, 1, 5 by 3. So this will become 0, 0, and next term is, this will become, so we multiply by 8 and then add. So plus 8. So 8 into 5, 40 by 3 plus 1. So this is 43 by 8 bata 3, 40 by 3 plus 1. So this is 43 by 3. Now next term is again 0, 0, and third term is, so multiply by minus 16. So minus 80 by 3. If 80 by 3 and then plus 3, so this is plus 3. So this is minus 71 by 3, and this will become a x, y, z, and this is a equal to 0, 0 and 0. This is equal to 0, 0 and 0. Now, in order to simplify this value, so we multiply the third row, which is as 3 by 43, into third row, and fourth row, which is multiplied by minus 3 by 71, fourth row. So this will become a equation 1, 1, 1, 0, 1, 5 by 3. So this is a 0, 0, 1, and next is 0, 0, 1. Now this is x, y, z, this term, and next term is 0, 0 and 0. So next term is 0, 0 and 0. Now this is diagonal entry. So my aim is to reduce it as 0. So I will apply operation R4 at this place, R4 minus R3. So this will become a 1, 1, 1, 0, 1, 5 by 3, and next is 0, 0, 1, 0, 0 and 0, this term. So we get this value, and here this value is x, y and z. So I reduced this term in this form. Now simplify this term. So we get 3 equations. So 3 equations are here, which is a x, y, z, x plus y plus z equal to 0. So first is x plus y plus z equal to 0. Second is y plus 5 by 3 into z equal to 0. And third is z equal to 0. Now substitute this value in this equation. So we get y equal to 0. Now substitute these and these both at this place. So we get x equal to 0. So what we get? We get a trivial solution x, y and z. All these variables are 0. So this is a trivial solution. So this is a trivial solution of the given system of equation. So which prove our result. So in this way we can find the solution of the given equations, given system of equation. Now next type is very important and it is expected for examination. How we can find the basis and dimension of the solution space of the system of equations. So next statement is find the basis and dimension of a solution space which is equal to W of the system of equation. So which are x plus 2y minus 4z plus 3s minus t, which is equal to 0, x plus 2y minus 2z plus 2s plus t, which is equal to 0, 2x plus 4y minus 2z plus 3s plus 4t equal to 0. So this is a system of equation. And how we can find the basis and its dimension. So this is very important time. So our first step is convert this equation into matrix form. So first of all, the equation can be reduced into matrix form. Now this is solution. So this can be written as 1, 2, minus 4, 3, minus 1, 1, 2, minus 2, 2 and 1, 2, 4, minus 2, 3 and 4. So this is x, y, z, s, t, and this term is 0, 0, 0. This term is 0, 0, 0. So this equation can be written in the matrix form. So what is that matrix form? Which is Ax equal to 0. Now here A is matrix of 1, 2, minus 4, 3, minus 1, 1, 2, minus 2, 2 and 1, 2, 4, minus 2, 3 and 4. So this is a matrix. Now in order to find the basis and dimension, so we reduce this matrix into row reduced echelon form. If we reduce it as row reduced echelon form, so just see that. So first R2, which is R2 minus R1, R3, which is R3 minus 2R1. So this will become 1, 2, minus 4, 3, minus 1. This will be 0, minus 1. This is again 0. So this will be 2. And this will be minus 1. This will be 2. Next, minus 2, 0, 0, 8, so it is a 6, minus 6, so this is a minus 3, and here it is a 3, it is a 2, 2 plus 4, which is a 6. So this is my first step. Now second step, so this can be easily make 0, which is R3 minus 3R2. So this will become 1, 2, minus 4, 3, minus 1, 0, 0, 2, minus 1, 2. So this will be minus 6. So this will be 0, 0, 0, 0 and 0. Now we make this term 0 or this term 0. So this can be, so we make this term 0. How we can make this term is 0? So just R1, this is R1 plus 3R2. So this equation will become, so third row is same, and next is 0, 0, 2, minus 1, 2, and after that this term. Now this is first 1, 2, same. So this is 6 minus 4, so this will be 2, and minus 3 plus 3, which is a 0, and again this term is, which is a, this can be written as this can be written as 3, 6, so this is a 5. So we reduce this equation in this form. Also we can also make it, this term is 0. So this will be non-zero. If you would like to make this 0, then this will be non-zero. If this is non-zero, then this will be 0. So any one of these two terms will be 0. Now the given system of equation will become x plus 2y plus 2z plus 0s plus 5t equal to 0. This is first equation. Second equation, 2z minus s plus 2t, which is equal to 0. So these are only two equations. So understand this concept. Now from this, x can be written as minus 2y minus 2z plus 5t minus 5t. It means x depends upon three variables y, z and t. Now this z depend upon two variables s and t. So which is s plus 2t. So this depends upon this z depends upon s and t. The s depend upon z and t because it is depending upon these three variables y, z and t. So this, if it depends upon y, z and t, and this depends upon s and t, if we substitute the value of this in this equation, so x will be minus 2y minus 2s and minus 4t minus 5t. So this will become a minus 2y and then minus 2y minus 2s and minus 9t. So x depend upon y, s and t. So remember that x depend upon y, s and t, and z depend upon s and t. So it means it depends maximum on three variables y, s and t. So if it depends upon maximum on three variables y, s and t, so we write these equation in this way: x is equal to this x, which is equal to minus 2y minus 2s minus 9t. This is equation number x. And this y can be written as 1 into y plus 0s plus 0t. This. Third is z. So z here the value is given. So 0y plus 1s plus 2t. This values. And next is s. So s can be written as 0y 1s 0t. This values. Next is t. T can be written as 0y plus 0s plus 1t. So this value, this equation can be written in this way. This is the entire x, y, z. This can be written as equal to first vector into y, second vector into s plus third vector plus third vector. So this is plus third vector into t. So we write these x, y, z, x vector into combination of three vectors. These vectors are minus 2, 1, 0, 0, 0. First vector. Second vector minus 2, 0, 1, 1 and 0. Third is minus 9, 0, 2, 0, 1. This values. So this x, y, z is a combination of three vectors. It means these three vectors is the basis of solution space. These three vectors, first vector minus 2, 1, 0, 0, 0, second vector minus 2, 0, 1, 1, 0, third vector minus 9, 0, 2, 0 and 1. These are three vectors. So these are the bases of solution space. So bases of solution space. Solution space W. So here I write it as W. And what is dimension? So number of vector. So dimension of solution space, which is equal to 3. So this is a dimension of solution space, and these are the vector in the basis, or it is a dimension of the solution space. Now in this case, remember that the vector in the basis is not unique, but dimension is unique. So the vector in this basis is not unique, but dimension is unique. So dimension will always unique, but vector in the basis, but basis is not a unique. So this is in this way we can find the solution space of the system of linear equation, that we already know that if Ax equal to 0 and rank of A is equal to R and A's order is n, so number of linear independent vector are n minus R. So similarly in this case, the A is the number of columns are 5, so for column are 5, and rank is so find the rank is 2, then it means 5 minus 2, that is a dimension. So which prove this is very important type. So in every exam it will be asked find the basis and solution of the system of equation. So for practice, do these two questions, find basis and dimension of solution space of following equations. So first is A part. So first part is x plus 2y plus 2z minus s plus 3t equal to 0. Second is x plus 2y plus 3z plus s plus t equal to 0. 3x plus 6y plus 8z plus s plus 5t equal to 0. And second question is B. So what is B? The equation of B is x plus 2y minus 2z plus 2s minus t equal to 0. X plus 2y minus z plus 3s minus 2t equal to 0. Third is 2x plus 4y minus 7z plus s plus t. So plus t equal to 0, right? So find the dimension and basis of these two equations. So its dimension is 3. So answer of this dimension is 3, and again its dimension is 3. So dimension of solution space is 3. So do it yourself. So this type is very important for examination.